Hello everyone, myself Srikanth V Katkur, Assistant Professor, Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. At the end of this session, student will be able to classify fluid flow. These are the contents we are going to discuss in this today's lecture: steady flow and unsteady flow, uniform and non-uniform flow, classification of any fluid flow in 4 categories, and the categories are steady uniform flow, steady non-uniform flow, unsteady uniform flow, unsteady non-uniform flow. First we will discuss what do you mean by steady and unsteady flow. The classification of the fluid flow based on the variation of flow parameters with time characterizes the flow in 2 categories, and the categories are the steady flow and unsteady flow. Let us discuss one by one. Now, what do you mean by steady flow? If the flow parameters such as velocity, pressure, density and discharge may differ from point to point but do not change with time, that type of flow is called as steady flow. And unsteady flow is defined as if at any point in the fluid flow the flow parameters changes with the time, the flow is described as unsteady flow. Now I will explain these 2 types of flow with by example. Now consider these fluid particles are there, and at time t1, time t1, let us say the properties are velocity is v1, temperature is t1 and pressure is p1, and after a particular period of time the velocity is v1, the temperature is t1 and the pressure is p1, means the parameters are not going to change with respect to time, then that type of flow is called as the steady flow. If you consider another time interval also, means at time t equal to t3, then this property will remain same, then that type of flow is called as steady flow, means at t3 v1 t1 p1, then at t4 also v1 t1 p1, means the properties or the parameters are not going to change with respect to time. That type of flow is called as steady flow. And whereas unsteady flow, the properties or the parameters are going to change with respect to time, that type of flow is called as unsteady flow. This is all about the steady flow and unsteady flow. Moving towards the next category or type of flow is uniform and non-uniform flow. The classification of fluid flow based on the variation of fluid parameters with distance or space, means in steady flow that is with time, and in uniform and non-uniform flow that is with distance or space, characterizes the flow in 2 categories, that is uniform flow and non-uniform flow. Let us see one by one. Uniform flow. Fluid flow is said to be uniform flow if the flow parameter that is velocity is constant with distance or at every point along the flow path at the same time instant. This is called as uniform flow. Whereas non-uniform flow, if at a given instant the velocity is not same at every point, means the velocity is varying at every point, that type of flow is called as non-uniform flow. I will explain this by example. Now consider the fluid flow along a river, then the fluid particles are moving in this direction. Now here if you measure the velocity at any point in this section, the velocity is going to remain same. This seems to be the velocity is constant. Therefore that type of flow is called as uniform flow. If you measure the velocity here, if you measure the velocity here, if you measure the velocity here, that it seems to be constant. Therefore that type of flow in this zone is called as the uniform flow. Now here the turbulence is present. Due to this turbulence the velocity is going to change. It creates a turbulence, therefore there is change in the velocity. If you measure the velocity at this point, it is different. Here if you measure the velocity at this point is different, here also different, means the velocity is not constant along the consideration of this path. Therefore this type of flow is called as the non-uniform flow. Here velocity is constant, therefore uniform flow. Here velocity is not constant at every point, therefore non-uniform flow. This is all about the uniform flow and non-uniform flow. Now this steady flow and unsteady flow and uniform flow, that will be applicable for any type of flow, any fluid flow, that will be categorized into 4 categories. And the category classifications are steady flow, steady uniform flow. Now in steady uniform flow, now we know steady is related with time and uniform is related with the space or position. Therefore, steady uniform flow, the conditions do not change with position and time. If in a given situation, if the conditions are same with position and time, then that type of flow is called as uniform flow. Moving towards the next classification, steady non-uniform flow. In steady non-uniform flow, conditions changes from point to point but does not change with time. Means after some time the properties are going to remain same, that's why the steady is there, and the conditions are varying from point to point, therefore that is non-uniform. This is called as the steady non-uniform flow. Moving towards the next, unsteady uniform flow. At a given time of instant, the conditions at every point are the same, therefore uniform flow, but will change with time, therefore unsteady. This example is of this is unsteady uniform flow. Unsteady non-uniform flow. At a given instant of time, the conditions at every point are varying with position and time. That example is called as unsteady non-uniform flow. Now think on this question. Classify the type of flow for water flowing through a pipe of uniform diameter. Now the answer is steady uniform flow. Why, that I will explain. Now the flow of water in a pipe of a constant diameter, if you measure the parameter at any section, that will remain same. That may be velocity, that may be pressure, that may be discharge, that may be density, as water is incompressible. Therefore, if you measure the properties at every point, that is remains same, that's why the flow is steady. And if you measure the velocity at any point in that flow, if the diameter is constant, then the velocity at any point that is remains constant, therefore uniform flow. Therefore this is the example of steady uniform flow. Moving towards the next category example, that is steady non-uniform flow. Flow in a tapering pipe with a constant velocity at the inlet. Now, why this example is steady non-uniform flow? In a tapering pipe, at a particular section, the velocity, it seems to be constant with respect to time, but as you move with respect to the distance, as due to the taper, the velocity is going to increase. Therefore, that the velocity is not same at every point, therefore that is non-uniform flow. But at a particular point the properties are the same, therefore that is steady. Therefore this example is of steady non-uniform flow. Moving towards the next, that is unsteady uniform flow. A pipe of constant diameter connected to a pump, pumping of a constant rate, which is then switch off. Now how this is unsteady uniform flow? Now initially the pump is supplying the water with a uniform rate. Okay, when you switch off this, let us say initially the velocity is 20 meter per second, and after the switch off, then it will cut off the supply, therefore the velocity is going to reduce, means it is going to reduce up to 0. Now if you measure the velocity at any point at initial stage, the velocity is 20 meter per second, then we switch off, then it is going to reduce, but at every point the velocity is going to remain same, means initially 20 at any point, then after switch off, then it will reduce to 0, 50 meter per second at any point, 10 meter per second at any point, then 5, then 2, likewise. Means the flow is uniform, but it is changing with respect to time, then that type of flow is called as unsteady. Means from 20 to 0, that means properties are not going to fix with respect to time, therefore that is unsteady. Therefore this is an example of unsteady uniform flow. Unsteady non-uniform flow means the conditions are going to change with respect to time and space, and the simple examples is waves in ocean. These are the references. Thank you.